Okay, in this video, I'm going to roughly run you through this pretty straightforward question from MJ16 Paper 52. By the way, whether you get an easy or straightforward question really depends on your luck, I guess, because there are certain questions which are easier and certain questions which are harder. I would actually argue that it is not a bad thing to get a harder equation or a harder analysis, because this means that the requirement to get full marks will be easier. If the question is as simple as this one, then almost everyone will get full mark, which means that if you make a careless mistake, it will be in your disadvantage. Anyway, let us read the question first. A student is investigating how the resistance of a wire depends on the diameter of the wire. The circuit is set up as shown in figure 2.1. So we are connecting an ohm meter directly to the wire and just measuring the resistance. Okay. Experiment is repeated for the wires of the same material and same length. So I guess this one could be important. So I'm just gonna highlight this. Same material, same length, different diameter. Okay, so same material here means you will have the same resistivity. It is suggested that R and D are related by the equation R is equal to rho L pi D square. So we have same. Okay, I'm going to highlight all the constants. Resistivity is constant, L is constant, 4 is constant, pi is constant. Wonderful. So we already identified our variable. We will take wires of different diameters and measure the resistance. Not we, they took already. So a graph is plotted on the y-axis of R against 1 over d square. Determine an expression for the gradient. So for this question, you can see that I can rewrite the equation slightly, and this will be 4 resistivity length over pi multiplied by 1 over d square. And you can see that this is the y-axis, and this is the x-axis. So if you compare with the general equation of a straight line, the 4 rho L over pi will conveniently be equal to the gradient. Very nice. So you can write your answer for all of 1 mark. So we're gonna write here that the gradient is equal to 4 rho L over pi. Okay, pretty straightforward. We're gonna move on to the next part. Now this is what I meant by from the intro video by you will be given data. Don't worry. Okay, so the table is always partially complete and you have to complete everything. Calculate and record the values for this in figure 2.2. So you can see, right, this table header is empty. So you are expected to transfer this detail to here. Every year is different. Sometimes they are very nice, they give you everything. Sometimes they don't, they just tell you that, oh, find the value of 1 over d square. Then you need to know the unit. Okay, so sometimes they're also a bit tricky, because if you note this unit, right, there is actually a prefix here. So while you transfer over, you notice that there's a prefix here, 10 to the power of 6. So all your answers must be written 10 to the power of 6. Okay, so we'll calculate that later. So this is probably 1 mark. The values is 1 mark because this whole thing is 3 marks. Right? And then, oh, we have to find the absolute uncertainties in 1 over d square. So this is what I meant by using identities. So if you are actually a bit observant, these 1 over d square, some people will say this is d to the power of negative 2, right? So if you write this as d to the power of negative 2, then you're a bit stuck, because then you go like, oh, uncertainty in d over d is what, negative 2. What is happening? Okay, so for this one, I generally don't suggest that you do it this way. Okay, so what you can do is you can treat 1 over d as its own expression. Okay, So let's say you want to find the uncertainty in 1 over d square. So then you will divide by the value of 1 over d square. And when you calculate 1 over d square, what values did you use? You use d. So there's an uncertainty in the diameter, divide by the actual reading of the diameter. So what I'm trying to say is that the percentage uncertainty of 1 over d square will be the same as the percentage uncertainty of d. But because there's a square here, this whole thing will multiply by 2. If you're very hell-bent on taking out the square to follow the identity, then you can rewrite it this way lah. Then the square outside though, but I don't think it's that important. So I'm just going to leave it that way. Okay, so the idea is that the percentage uncertainty in 1 over d square and this one must be the same. Okay, and whenever you follow this thing, you have to follow their units. You cannot put whatever unit you want. There's a reason why they gave you this. So question is king in paper 5. If the question asks for this, you give the question something else, the question will not give you marks. Pretty transactional and simple to understand, right? Okay, so based on this, we can calculate the value of 1 over d square. You already have d. D are these values, right? So if you take 1 over 0.91, your calculator, you will notice that this is 1.21. Okay, you might be thinking, how many SF again? So let me give you a refresher. This thing is 2 SF. So when you transfer over here, this will be 2 or 3 SF. It's the same method that we applied from our paper 3. Okay, so everything here is 2 SF. So you reach everything here. You can either write 2 or 3 SF lah. But please be consistent. Okay, don't first line 2 SF, second line 3 SF, then go back to 2 SF, then go to 3 SF. This is a not healthy relationship. If you decide to use 3, you will stick to 3. So we will proceed with all of this, 1 over d. So I'm assuming that pressing the calculator should be pretty okay for all of us. Please remember to bring your calculator this time, guys. If you're a type that I always forget to bring my calculator, maybe you can pass your calculator to your friend for safekeeping, a friend that you can trust, so that they will bring for you. Okay, so you press all of this, you get this. Okay, so eventually, right, when you arrive here, you will notice that the decimal point will shift because we are trying to maintain 3 SF. Once again, it's a calculated value. We are not checking decimal point. We are actually just checking the the significant figure. Okay, so we have already recorded the values. We have calculated absolute uncertainty in 1 over d square. Okay, so we need to find what is plus minus. So I will do 1 for the first reading, and the same process will repeat again for all 6 readings. So you are looking for the uncertainty of this thing, 1 over d square. 1 over d square. Okay, what is our actual d? 1 over d square, 1.21. This will be equal to the actual uncertainty in d, which is 0.01 here, divided by the reading of d, which is here. I will highlight later to show you if it's a bit all over the place. Don't forget to times 2. Okay, so when we transplant the values, this is what we are moving around. Okay, your 1 over d square is 1.21 because this is your 1 over d square. Okay, your value of d here is 0.91. There, 0.91. This is d1. Okay, so you have to be very careful when you bring values, you know. Don't just happy, throw here, throw there, and then go and collect the wrong value. Then if I'm marking your paper, I'll be staring at it, wondering what is happening. Spend a few minutes of my life, and then notice that you totally used the wrong values, and then, oh well, oh shucks, 0. Okay? Can? So hopefully that is clear. So this is how you transfer, because you're looking for the percentage uncertainty. All right, do as slowly as quickly as you need. to calculate the uncertainty. So this absolute uncertainty, there's a slight difference here. You could write 1 or 2 SF. Let's say you stick to 1 SF lah. This will be 0.03. Okay. Generally, okay, you need to think a bit. If you take 2 SF, it might seem nicer, but the problem here is your error bar will be very difficult to draw because you cannot draw corner plots. Okay. Then the second problem is you also kind of need to follow the decimal point of this one, right? So if you go and take 2 SF here, then a decimal point don't follow already. So you are trying to balance between both. I need it to ideally be 1 SF and follow this decimal point, which happens to follow the significant figure of this one. So there are actually quite a few things to think about. Okay, so this will be plus minus 0.03. Okay, so we'll repeat this calculation for all the remaining one. Okay, you can pause the video and try right now. Okay, we're back, and you can see I've already calculated all the uncertainty. Wow! Alright, a few things. You will notice that they are not all 1 SF because, you see this one? So it's 3.19. I'm trying to stick to the decimal point. Miss can meh? I'll show you the mark scheme later. Okay, so these are all okay until you arrive here. So oftentimes, what I will see from people is that they will write 1 because the uncertainty for this by calculation is 1.02. So we're not writing 3 SF, it's 1. So sometimes people write 1. If you write 1 here, then this cannot be 13.7. If I'm marking, I'll minus mark. Alright. So if it's 13.7, 1 decimal point, you stick to the decimal point, 1.0. Okay. So don't forget that. You might think this calculation is very troublesome, but I find that after a while you press this, it's actually quite fast one. The longer version is for you to find the max and mean value and then subtract. Okay, so I will very quickly demonstrate how to find the max and mean value for the first reading, and then the rest you do yourself lah, okay? So this is the first method. So this is method 1, using identities. My preferred method. Method 2, the fail-safe, the insurance plan, half the range. So I need to find what is the maximum value of 1 over d square, max. So I look at the reading of d. The first reading of d is 0.91 plus minus 0.01. So the biggest possible value for this is 0.92. The smallest possible value is 0.90. So here, I will put this one as 1 over 0.90 because it's the denominator square. And this will give me 0.9 square. 1.23. I guess if you want, you can take more SF lah, but this is fine for me. Then repeat again for minimum, which is 1 over 0.91. Wait, 91 plus 1, 92 square. So let's do that. 1.18. So hence, the uncertainty of 1 over d square will be half multiplied by the range 1.23 minus 1.18. Guys, you can see how painful this can be because, so this will be 0.025 written to 1 SF, it is 0.03. So you can see it's the same number, or it will be close to each other. Okay, do this method if you totally cannot derive the identity or you are not confident. But you also have to understand, this is where your page ends, and you have no extra space for working. So if you're going to do this calculation for 6 reading, where on earth are you going to squeeze it? Are you organized enough in your head to actually do this in your calculator properly? You need to think about strategy, guys. You cannot start war. You cannot go in a battle without a strategy. So hopefully all the exercises that you do before the paper is a strategy plan for you lah. If you do this, you have to know how to organize all the numbers. You make one mistake, then everything here domino effect. You are working so hard for how many marks? 1 mark. Huh? Yes, I think they expect you to already know this. So think about your strategy. Must strategize a bit ma. You have limited time, you have limited space, and one error will cost you the entire mark. Yeah lor, only 3 mark leh. No the 3 mark is not everything You find the absolute uncertainty is 1 mark. This one all correct, 1 mark. All these values correct. This 1.21 3.19 all these you never press wrongly. This is 1 mark. GG oh. So sad, right? It's okay. You level up already ma. So they assume that this is easy for you. So yeah. Okay. Miss, where is the 3rd mark? Oh, I mean, I give you a good news lah. The 3rd mark is here. This header is the 3rd mark. Very nice. You copy this thing here, you get 1 mark. All the DP, SF that you used to have in paper 3, you are expected to transfer. So if let's say you never follow the DP or the SF rule for all this value of 1 over d square, let's say for example I see 7 here lah, for some reason, don't know why you put 7. Then I straight away give 0 already. So everything must be correct. The calculated value must be correct. The significant figure must be correct. So everything that used to give you a lot of marks in paper 3 is just now 1 mark. 1 error, you get 0. Okay. Alright, so that's 3 marks here for the table. Practice. Plot a graph of r against 1 over d square. Dude, if you plot the graph wrongly, cannot help you, okay? So please always double check or plot this one against this one. Sometimes you might have actually several columns. So I chose the easiest question. Okay, there are harder questions, and as you level up, you will notice that sometimes people can plot the wrong graph. Then that will be a bit sad lah. Okay, include the error bars of 1 over d square. Okay, once again, I'm just going to do for the first value, and you do for the remaining 6 value. Okay, and then part 2, draw straight line of best fit and worst acceptable straight line on your graph. Broad lines should be indicated clearly. So here they are trying to be helpful. They are reminding you to label the lines. If you no label, you no get mark, it is a sadness. But it is nice for me if I'm marking, because when I don't see label, right, I just give 0 out of 2. I don't have to check your why. I don't have to check anything. It's very nice. So if you want to help your examiner, you can either help by providing perfect answer or just not doing your work properly and then just get 0. No. Sadness. Okay, so we're going to do this part first, plot the graph, and then draw the best fit line. So the first reading is 0.91, 1.21. Wow, they give us the axis. Yes, very nice. But if you notice, Miss, you see they use odd scale. You tell me not to use odd scale, and yet they use odd scale. Aiya, you know the adults, they say, do as I say, not as I do. CAIE is a bit like that lah. So certain things that they want you to do, they are not very strict in following as well. One could also argue that Miss, it's still 2 units for 2 boxes. Yeah lah. But to me, this is still very odd. So again, they are CAIE. They can do whatever they want. You are a student trying to get an A. You have to do what they want you to do. Okay, so the first reading was on the resistance. It was 0.91, 1.21. So I'm just going to write down the coordinates, okay? I'm trying to plot 1.21. It's my pen. 1.21. The 1 over d square is the x-axis, and 0.91. So 1.2 will be somewhere here, and 0.9 is... Where is 0.9? 0.9 is about... So you can read until 1. Miss, can read in between. No. So you cannot plot 0.9. There's no in between. Okay? It's like When you date someone, there's no in between. You cannot be in between two girls or two boys. Cannot. Must choose one. So if you think about whether to round up or round down, you have to find out which corner is closer to the reading. Okay? 4 boxes is 0.8. 5 boxes is 1.0. So 0.91 is closer to 1.0. So we plot 1.0, okay? I repeat, 0.91 is closer to 1.0 compared to the alternative, which is 0.8. Okay, oh wait, should I plot here? No lah, hang on, I should take this point. Okay, 1.21, where is 1.21? This is 2. So 1.2 will be 1 box, lor. 2, 4, 6, 8, 10. So your plot is here. Make sure that your plot is not big. This is the biggest you can go liao. No bigger than this. Okay, you might be thinking, how do I make sure that the examiner can see? Use a pencil and draw clearly. Okay, sharp pencil. Mechanical pencil is the best for drawing graph. Okay, so something like this one. Okay, what about the error bar? The error bar was plus minus 0.03 because the reading for 1 over d square, the actual reading for your 1 over d square was 0. Is it 0.91? Did I plot correctly? Oh no, it looks something wrong. Is it something wrong? No, correct. Hang on. I also don't know what I'm talking about. 1.21 plus minus 0.03. How many boxes is 0.03, guys? Somehow you want to take 0.025. Nagila cannot fit. So 0.03. One box is 0. This one, left and right. One box would be 0.2. So can you even fit 0.03? Because this is 2 ma. So 1.2, 1.4, 1.6, 1.8, 2. Can we even fit 0.03? Uncertainty too small, no need to plot. So, no, you have to plot the uncertainty. So when it is smaller than 1 box, my recommendation is to draw 1 box. I have the luxury of changing color. You use pencil all the way, okay? On your actual paper. So your error bar, you will draw this way. So you draw from 1 box to 1 box, 1 box to 1 box. Cannot fit. So something like this. Symmetrical. Please use ruler. Don't freehand like me. Okay. So if it's too small, you draw at least 1 box because all error bar must be drawn. So what this tells me is that your uncertainty, this is your uncertainty, the smallest possible uncertainty. Again, no corner plots. Okay. That's all. You could say, oh, Miss, can you show one where there's actual uncertainty? Can I take the biggest one? No. Where's the biggest one? Let's go here and see. 0. Do you notice that there's an error? You see? What else do we do? So you can see it's very common. Then the student just finish everything only because every point lies on the graph. I'm smiling because I've seen it before. Then I'm like, why? What happened? Then on the days they plot this one against this one. Or maybe they can plot like 4 points, wasted 10 minutes, and then notice, oh shoot, I plot the wrong axis. What are we plotting again? R against 1 over d square. Hiya, good thing we use pencil. So we rub lor. What is R? Scroll up again. R is 1.6. So the 1.21 is okay. But this point has to be at 1.6. Sadness. Sadness. I'm just trolling people. Because everyone is like very confident when they go out, then notice that their gradient and their friend's gradient is not the same, then immediate panic ensues. Okay, so your R is 1.6. R is here, this is your R axis. So always double check before you start. Where is 1.6 again? This is 1. Okay, let me zoom in again. Load. Okay, 1, 2, 3, 4, 5. This is 1. 1.6. 246. So 1.6 is here and 1.21 was here. So your point is here. Did you now plot the right point? Dude, if you use pen to draw paper 5, happened once before when I was invigilating. Had to run to the exam unit and get the candidate a fresh paper. That is only because the person was lucky. The exam unit got extra paper. What if the exam unit no extra paper? Then you GG lor. So please use pencil for this one. Normally I insist when you're supposed to use pen, use pen. Here is where you use pencil. Okay. So this one, no problem. Make sure you plot the right axis because you can very well plot almost all the points here and then halfway you know you're wrong now. Okay, so we're going to repeat for all 6 points and now I'm going to take the last one. 19.5, 13.7. 19.5, 13.7. Okay, so here is where it becomes a bit hard because you're quite far from the axis. Let's do 19.5 first. So 19.5. Okay, 19 is at 5 boxes. 1, 2, 3, 4, 5. This is 19. Let me change color. 19. 19.5 is somewhere here lah. Miss, do I round up or round down? It's halfway ma, doesn't matter. So let's say I round up lah. Okay, so 19.6 is here or 19.5 is here. And then your 1 over d square is 13.7. So scroll down. This is 13. So 13.7. You could think that you could round better if actually you repress your calculator and find out whether it's 13.71 or 13.74. But let's say we take 13.7 1, 2, 3, 4, 5 this is 13. 2, 4, 6, 7. Okay, so maybe somewhere here at this point. Okay, so you must make sure, again, I would like to remind you that your plot is not too big. This is the biggest, no bigger than one small box, corner to corner roughly. So this is the biggest size you can go, which is around the size that I'm drawing right now. Okay, don't draw too big. Okay, your uncertainty in D for this one, 13.7. 13.7 is here, right? No, this is 14.7. What am I drawing? Very hard to plot graph digitally, guys. I actually need a paper. 1, 2, 3. 13.6 is here. Okay. The hand-eye coordination. Okay, there we go. So the absolute uncertainty is plus minus 1. So it's plus minus 5 boxes. Wow. So you draw, use your ruler, draw out 1, 2, 3, 4, 5. Like this. Close the bar. You must end the bar. 1, 2, 3, 4, 5. End the bar. Okay. There will be no anomalies in your graph. So if you plot everything, you should get a really beautiful graph. You know why? Because they gave you the data, guys. So there should be no anomalous points. If there are anomalous points, you calculated something wrongly, you plot wrongly, the calculator is wrong, something is wrong, please recheck everything. Okay, so this is how you plot the graphs. So let's assume that you have done this exercise and now we're going to look at how to draw a best fit line. Alright, and I have magically plotted the graph. Okay lah, no lah, plotted on paper and then I scanned it. Because I can't draw this on OneNote. It's not going to happen. So remember we plotted this and we plotted this and you will continue to plot all the error bars this way. So one thing to note is that this vertical line of the error bar should be at most one small box on top and one small box below. But this one is fine. Half is fine. This is a very neat drawing if I do say so myself. Cough. Okay, so here to here lah. You can also draw two bars like this. Okay, so this is the longest you can go. Don't go and draw very long. Why? So this is a example of a good plot, good error bar, use ruler. So let's check out the best fit line. So you notice that the best fit line and the worst fit lines are labeled. The best fit lines will be fairly easy to draw. You check the point 1, 2. Okay, let me try to zoom in a bit. 1, 2, 3, 4, quite close to this one, 5, 6. So they are all very close to the line. If you have an anomalous point, you have messed up. Go check the calculation. So the best fit line is fairly straightforward to draw. What about the worst fit line? So there are two ways to draw the worst fit line. You can take the leftmost side of the top error bar, connect to the rightmost side of the bottom error bar. So then you get a steeper line. You can of course also take the leftmost side of the bottom error bar and draw all the way here and connect here. There's only one condition. Your best fit line must pass through all the error bars. So pass through error bar, pass through the error bar, pass through the error bar, pass through the error bar. Good job. This is a good worst fit line. Okay, so make sure it passes through all the error bar. If not, then how? Cannot level. So because everyone have the same data and everyone should be plotting a pretty identical graph, you should get very similar things. Okay, number 2. Next part. Yeah, see, I did this already. You'll find the gradient of the best fit line and the worst fit line. We are going to triangle. Draw a triangle. Draw a triangle. You notice that because everything is in black, your labels are very important. If not, no one knows what gradient you are looking for. Okay, so you can see the candidate has clearly indicated the coordinates here and here. So like a good person, you also indicate the coordinate. You find the actual gradient. Okay, that's not a problem. And then you calculate the uncertainty. So from the briefing video, we understand that the uncertainty in gradient is the difference between these two values. Please show your working. Like paper 3, if you don't show working, I can pretend I don't know how you get this number and give you 0. I don't know how you get the number. You never say also, never show also. How do you get 0.2? Don't know. Okay, so remember there's a prefix here. You find the gradient, you never include the prefix. How? Thank you, I take the mark away. Okay, so you don't need to include units if you don't want to, but the prefix have to be transferred, and the prefix was on the x-axis. That's why it's at the denominator of your expression. Okay, so this one I really have to slowly do one, and you might run out of time. If you're the type that very kanjiong, kanjiong is Chinese saying of panicky, you're very panicky and you're not steady one, I suggest you do question 2 first. This is a kind of question where you don't want to do this question when you got 15 minutes left and you are like red alert inside. Okay, so we have done this already, and then at the end, once we have the uncertainty for gradient, we can write. The standard uncertainty rules still apply. So you have to make sure that this one is 1SF and this one follow this one. Okay, so follow 1SF and follow the decimal point. All right, next part. Miss, I do so much work. I'm very tired now. I got an entire page left, guys. And you see all these 2 mark 1 mark 2 mark very sad. But you don't want the 5 mark, meh? You also want, right? Okay, so again, please don't reach this page with only 5 more minutes because you spend too much time doing all the previous part of the paper. Okay, using your answer in A, which is the expression for gradient, and the answer in C part 3, which is the expression for the value of the gradient, find resistivity, include an appropriate unit. Okay, so this one, the unit is 1 mark, and the actual calculation is 1 mark. You must substitute. Okay, so when you substitute values in, the gradient that we calculated previously was 1.42 times 10 to the power negative 6. Do you need to transfer this number or should you transfer this number? Up to you lah. As long as the calculation is clear. Okay, I generally think that it's better to transfer the number on the dotted line because this is what you declare. If this is what you declare, this is what you should use. Okay, so that will be 1.4 but this candidate took 1.42. It's okay because I can see from the person's calculation where the 1.42 comes from. Okay, so this one is given, you put inside, and then you write your answer. Generally, right, this kind of calculation, if you care about SF, you can see 3SF, 3SF, 3SF. So then you write 3SF. 3SF is always very safe. 2SF is generally also acceptable because we kind of expect some people to put 1.4 here. Okay, so the actual calculation is 1 mark, and then the unit. So the unit, there are many ways people will do this. For example, let's say you want to find the resistivity. What you took was you took the gradient, which is ohm meter square. Okay, and then you divide by the length, 1 over m, so you get ohm meter, which is why it is a good habit to transfer this unit meter negative 2 and this unit ohm back into this part when you calculate your gradient, because then when you transfer you know what unit this is, but this is a P3 scale. Okay, so you can take 1.4, you can take 1.42, 1.424 is also okay, depending on what you write there. Alright, so here you got the answer already for resistivity. Then determine the percentage uncertainty. Only 1 mark, so sad. But don't worry, you go and stare at this thing. How do you find resistivity again? You use gradient and you use length. So we take the uncertainty in gradient over gradient plus the uncertainty in length over length. Put inside all, substitute all, you get 15%. This one right in 2SF. Okay. So normally there will be a y-intercept calculation. This question is easy, there's no y-intercept. Okay. So next one. The experiment is repeated with a thinner wire. Okay, all different diameter, and the wire is same material and length. So we're going to repeat the calculation all over again. We already have resistivity calculated here, 1.12 times 10 to the power negative 6. So you can plug inside. Okay, same length, 1 meter. Got diameter, put inside. You can find R. R is around 27. Okay, so we determine the resistance of R already. Once we have the resistance of R, include the absolute uncertainty. Ayo, this one never end one. Okay, end now, going to end now. You find resistance, what do? You use the value of resistivity, which has its own percentage uncertainty. Okay, percentage uncertainty for resistivity calculated already, 15%, there, 15 over 100. Uncertainty of length, because you use length here, you substitute the 1, so this is 0.01 over 1, given here. Okay, and then uncertainty in D over D. So, diameter here. So calculate everything, 25%, and then you take 25 times 27, which is your reading, and you get 7. So then you get 27 plus minus 7, follow the general convention. And finally, the question is over. If you're interested on how this thing is being marked, let's hop on to the next video then. I will see you there. You will get there. Just need a lot of practice. Bye-bye.